Right, hi, I'm Dr. Eichmeyer. I'd like to welcome you to meteorology. And for those of you that think that you're in a class about meteors, it turns out meteorology is climate science. So we'll be studying the weather, climate, and looking at the various aspects and driving forces behind our weather conditions. And so I hope that you'll enjoy this class. I enjoy teaching it, and what I'd like to start with is just what is climate versus what is weather. Climate is, you could think of it as the clothes that you buy. You know, all of the clothes in your wardrobe would be ready for any kind of conditions that might happen throughout the year. Whereas weather is related to the clothes that you wear. So in other words, what we're talking about here in this analogy is the different ranges of conditions that are possible during a year. Whereas weather is related to the specific conditions that you experience today. So it turns out that today, as I'm making this video, there's a nasty heat wave moving through the whole area, and in Atascadero, where I live, the temperature was up at 110 yesterday. So that's pretty hot. I think it's supposed to get to 107 today. But you wouldn't say that that area is a desert. We'd say that we're in a heat wave. Okay? And so the heat wave then is associated with the weather, but the climate is, it's called the Digger Pine Zone, and it's got ranges of temperature that go from hot like today to very, very cold. You can have temperatures that get all the way down below freezing and during the winter time. And so there are, but not a lot of snow. And so those kind of conditions then would be associated with the type of climate that we have in this area. The San Luis Obispo area is sometimes considered to be a Mediterranean climate, in that it's similar to the kinds of conditions that you experience throughout the year around the Mediterranean Sea, especially in the southern Mediterranean. Now, what causes the weather? Well, turns out it's the sun. The sun drives weather conditions. How does it do that? Well, by unequal heating of the Earth's surface. Meaning that you have some areas that are getting heated more efficiently than others by the energy that's coming in from the sun. Why do we get unequal heating? Well, one, and this I think is kind of an obvious one, is that a certain part of the Earth at any given time of the day is pointed right at the sun, and another part of the Earth is pointed away from the sun. And so the position of the Earth as it rotates creates unequal heating. So in other words, day gets more light than night does. And if you're pointed straight at the sun, if the sun is straight overhead or as high in the sky as the sun gets during the day at your particular latitude, then you're expecting the most energy to be coming in from the sun. But then as the sun appears lower in the sky, or it doesn't appear in the sky at all, then that's when you don't have as much heating from the sun. So that is the principal reason for unequal heating, but there are others as well. Water absorbs 90% of the sun's radiation. Whereas ice reflects 90% of the sun's radiation. And so clearly then, liquid water is going to absorb solar energy way better than ice will. Only 10% of the energy from the sun is absorbed by ice, and that's one of the reasons why you can get a sunburn and snow blindness too when you are skiing in the wintertime, but not directly from the sun, but from the reflected light that comes up from the snow can give you the snow blindness and can give you an extra dose of solar radiation and a sunburn. And then land absorbs differently than water and ice. And certain types of land surfaces absorb energy better than other types of land surfaces, just because of the color of the rock, and also the mineral composition has a lot to do with how well each individual type of geologic structure absorbs energy. And so, because there is this unequal heating of the surface by the sun, what you end up getting then are tendencies for heat to want to move from hot to cold. So I think this is something we all know. More correctly, we say heat moves from high temperature to low temperature. And so how does that heat move? Well, the principal way in the Earth's atmosphere is called convection, which we define to be the transfer of heat by mass motion of molecules. So what do I mean by that? What are examples of convection that are associated with the weather? Well, the most important example is the wind. In other words, currents of air will deliver heat from high temperature regions to low temperature regions. And so this is part of what makes up our weather pattern. Another example of a convection pattern would be ocean currents, which, as we'll see, also affect our weather because the ocean has a certain temperature, and that temperature can be transferred to the atmosphere, which gives rise to another type of heat transfer, conduction happens when we have molecular collisions. And so this is the transfer of heat by molecular collisions. And so in other words, if I grab a frying pan with my hand, and the frying pan's really hot, that heat is being delivered from the hot frying pan handle to my hand by means of conduction. So there are collisions of molecules between the handle of the frying pan and the molecules in my hand, heat my hand up and deliver the heat to it. Now in terms of the weather, an example of this could be the conduction of heat from the oceans to the atmosphere. Okay, and so this is the way then that the heat which has been delivered to the earth by the sun can then be delivered to the atmosphere is by conduction. Then once it's in the atmosphere, then the wind can drive it around by means of convection. But how does that energy get to the earth in the first place? Well, that's by radiation. So that's the other method of heat transfer. And all three are used to create our weather patterns on the earth. So radiation then is the transfer of heat by electromagnetic waves from the sun. Or electromagnetic waves, in this context, constitute light, but also infrared, ultraviolet, X-ray. These are all produced by the sun. And in lower frequencies, microwave, and even radio waves. These are all different forms of electromagnetic waves that are produced by the sun, and those waves are delivered to the Earth, they're absorbed by the Earth, and then conduction transfers the heat from the Earth into the atmosphere, and then the atmosphere moves that heat around by means of the wind and ocean currents, what we call convection currents. And so all three of those methods of heat transfer then are working in tandem in order to produce the patterns of weather that we see on the Earth.